Hey guys, welcome back to Aisha's Academy, and today we're going for an AQA GCSE Higher paper. Fun fact, so I actually did AQA. I didn't really do Edexcel, but I've noticed as well there's not many people that tend to post AQA past papers, so I'm here trying to support you all and posting one to go through today. So I have done an Edexcel Higher and Foundation one. I'll stick those links in the description box down below in case for those of you that are doing Edexcel. But for my AQA peoples, I'm going to be going through this one with you. So, higher paper, let's go. All right. So, if we have a look at question one. So, question one, 5 to the power of 4 and then bracket squared. So, what that basically means is whenever you've got a bracket around a power, you're going to end up multiplying the powers. So, you end up doing 4 times 2, which is 8. So your final answer would be 5 to the power of 8. So it'll be that one. That's it. Then it says circle the volume in centimeters cubed of a cylinder with a radius 5 centimeters and height 8 centimeters. So if I draw a little cube, just so you guys can get a little perspective. So the radius, right? So I'll zoom out into the circle part of the cylinder. So the radius was 5, its height is 8. And in order to work out the volume of a cylinder, it is volume is equal to pi r squared times height. So the area of a circle times height. So we know the radius is 5. So pi times 5 squared, which is 25, times the height, which is 8. 25 times 8 is 200. So what was that? 200. So 200 pi. And that's that. Then it says 16a squared. I'll zoom in. So there we go, nice and clear. Right, so 16a squared divided by a plus 3a times 2. So we're going to be using a bit of BODMAS to help us answer this. So if you remember BODMAS, any time that you get equations and it's got all the different signs, use your BODMAS. So in our BODMAS, we've got division, addition, and multiplication. So we've got these 3. But as we can see, our division is first, so we're going to divide first. So we're going to do 16a squared divided by a. When we do that, we would be left with just 16a, right? So then that's that. Then after divide is multiply. So what we need to do is we need to do 16a plus the 3a times the 2, right? So because multiply comes first, we are going to multiply the 3a times the 2 first. So then that's going to leave us with 16a plus 6a. Add them together is 22a. So please, guys, always refer back to BIDMAS or BODMAS. It depends how you learn it for these questions. So moving on to question 4, we've got a bit of cos 30. So for higher spec, they are expecting you to know your values for your sine, cos, and your tan. So I'm just going to quickly plug you with this. So sine, cos, 0, 30 degrees, 60, 90. Right, so we know that sine 0 is 0, that cos 0 is 1, sine 90 is 1, cos 90 is 0, sine 30 is a half, cos 60 is a half, and so I've missed one out, haven't I? Sorry, go back. 45 degrees, 60 degrees, 90 degrees, there we go. Yeah, that is a half down there. This one is root 3 over 2. This one is root 3 over 2. And then that's root 2 over 2, root 2 over 2. And then we've got 1 and we have 0. So know these values, okay? So therefore, looking at the table, our cos 30 is root 3 over 2. So that's what we're going to circle. All right, good. So Looking at, just memorize that table. That's literally the biggest advice I can give. Memorize the table. Okay, so looking at question 5, it's now got a division fraction question. I do have a video on fractions high up above if you want to refresh your memory on that. So we want to give our answer as mixed numbers. So the first thing we're going to do, change them both to top-heavy fractions. So remember to change the top-heavy times the big number by the denominator and add the answer of that to the numerator. So 8 times 2 is 16 plus the 1, which is 17. Denominator doesn't change. And then we're just going to do the same for the second fraction. So 2 times 3, which is 6, plus the 2, which is 8. So then again, the denominator is not going to change. Then we've got, oh, sorry, not 8 over 2, 8 over 3. Then with dividing fractions, the technique is the second fraction, we're going to flip it upside down. So it's going to end up being 17 over 2. And when you flip it, it's going to now change to times 3 over 8. Multiply them together. That would leave us with 51 over 16. Can we simplify this? No, we cannot. But then because it wants us to leave our answer as a mixed number, we need to do that. So then in order to change this to a mixed number, our final answer would be 51. Oh, sorry, not 51. It'll be 3. The reason why it'll be 3 is because the most amount of times that 16 can go into 51 is 3. And then you're left with 3, and then 3 over 16. And then if you want to double check that your answer is right, what you can do is times the big number by the denominator and add the top. Yeah. So I hope that helps. So that would literally be your final answer. All right, so moving on to question 6. So question 6, we've got a ship and it's sailing and in a straight line from its home port. So basically we need to work out its speed. So really and truly you're thinking about that speed is equal to distance divided by time, an equation that you may see if you do physics as well. So we're looking at the time during the 4 hours. So 4 hours is over here. Yeah, sorry, we're looking at the speed during 4 hours. So if we're going to be doing distance divided by the time, what we need to do is we need to look at the distance from 4 hours, from 0 to 4 hours. So look, we formed a mini triangle. So the distance from 0 hours to 4 hours. So here at 0 hours, sorry if I remove the dot so I can just see the figure clearly, it's looking like it's landing at around 48. So each square, so we've got 5 squares for 20 miles. So then each square would be 4 miles. So then because we've got 2 squares, it would be 48. And then in terms of the distance at 4 hours, if we look, so we said that each square is going to represent, so 1 square was equal to 4 miles. And if we have a look here, from 100 miles, we've got 4 squares, so 4 times 4 is 16. So that point here is equal to 116 miles. Now, for the total distance for the 4 hours, we're really and truly only looking at that gap. So we're going to do 116 take away 48. 116 take away 48 would leave you, so we can do column method quickly to work that out. So borrow the 1, that'll leave us with 8, borrow the 1 again, 0, borrow the 1 again, that's going to leave us with 6. Yep, so that's left us with 68. So then in terms of our distance divided by time, that means that they covered 68 miles in 4 hours. So we're going to do 68 divided by 4, and the technique of dividing by 4 without your calculator is half, then half again, aka divide by 2, then divide by 2 again, which is going to leave us with a wonderful answer of 17 miles per hour. Okay. Then having a look at question 17, it says the sum of angles in a quadrilateral is 360. So Zach thinks that based on that to work out the sum of the angles in a pentagon, all he would have to do is 5 times 90 degrees, which is 450. But do we think Zach is right? Well, unfortunately, Zach is incorrect. And the reason why he's incorrect is because the formula for working out interior angles, which I mentioned in my video of angles in polygons, which is in the link above, and I'll put it in the description box down below. So interior angles, to work it out, is your number of sides minus 2 times 180. So in a pentagon, we have 5 number of sides, take away 2 times 180. 5 minus 2 is 3, times by 180 leaves us with an answer of 540 degrees. And therefore, because the total should be 540 and not 450, Zach is wrong. So moving on to question 8, we've got Kim works at an airport. So on the number of days, we're seeing that the number of planes that were landing between 10 a.m. and 2 p.m. every day. So it says that the airport was affected by fog on one of the days. Which day do we think it is? Well, if there was fog, you would have less planes land because it's poor weather, it's too much of a risk. And so really and truly, we're looking for the day that has the lowest number of planes, which is day number 8. And the reason why is because 102 is an outlier. So, aka, if you look at the rest of them, notice how they're like 150, 148 kind of thing. But 102 is just so out of place. And that's another way of knowing that that's the odd one out. So, 102 is an outlier, or you could just say it's the odd one out. Whereas the others are in the range 147 to 155. Anything along those lines, and they will give you a mark for that, as long as you just write some kind of explanation along those lines. So moving on to question 8b. So I'm going to zoom out since it's a part B in case we need to see part A. So it says Kim uses the data to predict how many planes will land at the airport in a year. Her method is that basically she uses an estimate of 150 planes in each 4-hour period throughout the day and assumes that the same number of planes for each day. So we need to now work out her prediction. So in a year, we have 365 days, except a leap year, but we don't need to be that difficult. So if we know in a year we have roughly 365, and she's saying roughly in a day, well, she's saying roughly in a 4-hour period. So in 4 hours, we have 150 planes. So if we know that in a day there's 24 hours, to get from 4 to 24, we times by 6. And so if we times 150 by 6, that will tell us how many planes will land in a day, which will give us a value of 900 planes. So we know in a day there's 900 planes. Luckily, we know that 24 hours is equivalent to 1 day. So in order to work out how many planes are going to land in a year, we need to do 900 times 365. Now, we do not have a calculator, no, but there's many multiplication methods that we can use without a calculator. There's the column method, which I'm going to do, and there's the box method. I'll show you quickly what I mean by the box method to refresh your memory. So for instance, if we were to have 900, you can split it out into 9. Yeah, you could just split out into 900, or and then in terms of the 365, you can have your 360 and your 5. You can multiply them all together. So that's one way of doing it, and then add everything together. Or you can do the Chinese method as well. But I'm just going to quickly do the column method. So 5 times 0, 0. 5 times 0, 0 again. 5 times 9 is 45. Then for the next one, add the 0 because it's 60. But then 6 times 0 is 0. 6 times 0 is 0. But then 6 times 9 is 54. Then because it's 300, the 2 zeros from 300. Then 300 times 0, 0. 300 times 0, 0. 3 times 9 would be 27. Add them all together. 0, 0, 5, 8, 2, carry the 1, 3. So you should be left with an answer of 328,500. So that's how we work that one out. Okay, moving on to question onto question 8C. So 8C, which is still a follow-up, so if we have a look here, we'll read it first, and if we need to go back to the data, I'll move the page. So 8C, it says, in fact, fewer planes land in winter than in summer, and it says fewer planes land at night than during the day. What does this tell you about Kim's prediction? So if it's saying that in winter there are fewer planes, and at nighttime there's fewer planes, then that technically means that Kim's prediction could be too high or too low. The reason why, I will explain. So the reason why her prediction is not necessarily too low is because just because it's fewer in winter than summer, we don't know. Summer could be a mad surge. So let's say in summer she could have more than 150 planes. Then that's going to counteract for the lower planes in winter. Even though it's saying lower planes in winter compared to summer and compared to from nighttime to day, we don't really know the numbers. And so because we don't know the numbers, we don't have enough information to predict whether it's going to be higher or lower. So watch out for those types of questions. So really and truly, if you know that it's not really giving you enough information, maybe some figures that you can relate to, then I would just always go for you can't really predict. All right, so moving on to question 9. Question 9, it's got 6 squared plus 8 squared square root is equal to the cube root of 125a cubed. So we can work out the first part. So 6 squared is 36 plus 8 squared, which is 64. 64 plus 36 is 100, and we know the square root of 100 is 10. So we know 10 is going to be equal to the cube root of 125a cubed. Then, if we cube 10, we are left with 125a cubed. We know that 10 cubed is equal to 1,000. So 1,000 is equal to 125a cubed. I'm just going to write it over here so you can see it clearly. So we know that that's equal to that. Then the next step is if we do 1,000 divided by 125, that's going to give us the answer of a cubed. We know if we did that calculation, we would be left with an answer of 8. And therefore, to work out what a is, we need to work out the cube root of 8, which is 2. So a is equal to 2. So that's one way that you could have worked it out. Another way that you could have worked it out is, let me have a look here. So if I put or another way that we could have worked it out is here, where you know that you've got the cube root of 125a cubed, you could have just worked out the cube root of 125, which is 5. So that'll leave you with 5a cubed, and we know that that would be, sorry, not 5a cubed, that would leave you with 5a. Because if we work out the cube root of a cubed, it's a lot of cubed going on, but that will just leave you with a. So 5a would be equal to 10. And so if you did work out what a is, it would be 10 divided by 5, which is also 2. So that's another way that you could have worked it out. So it's always good to show more than one root. But for now, I'm just going to quickly rub that out just so we can see the question 10 clearly. All right, so question 10, it says work out the percentage increase. Love these questions. So to work out any percentage change, you always want to do your new value, which in this case is 280, minus the original value over the original times by 100. So 280 minus 80 will just leave us with 200. 200 divided by 80 times by 100. So 200 times divided by 80, cancel the zeros, makes life easier for you. So you're left with 20 divided by 8. Then 20 divided by 8, if we were to simplify that fraction, we would be left with 10 over 4. 10 over 4 can be simplified, aka divided by 2 on the top of the bottom to leave you with 5 over 2. So if we end up doing 5 over 2 times 100, so we know that 100 times by 5 is 500. 500 divided by 2 is 250%. So that would be your final answer. All right, cracking on to question 11. So question 11, we've got 4 triangles. Which 2 triangles are congruent? Congruent basically means in maths, because in mathematics love to use words that most people don't use on a day-to-day. Congruent basically means the same. So we're just working out which 2 triangles are the same. So to help us know that which 2 triangles are the same, you want to look at which 2 triangles not only have the same angles, but then also their lengths are looking around the same positions as well. So as we can see, they all have 25 and 56, so that's not going to help rule anything out. But if we look at their lengths, even though they all have 8 centimeters, they're all kind of in different positions. So if we look at A, it's 8 centimeters is literally between the line of where the 25 and 56 is. Whereas if we look at C, it's 8 centimeters is not in that position. So A and C are not the same. Maybe if we look at also B's one is also not occupying that position either. So A and B are not the same. But then if we look at D as well, D is occupying that line between 25 and 56. So we can say A and D is the same. So just circle them. Nice and easy. Don't you just love AQA papers, honestly? So moving on to question 12, it's a solving question. Anytime you're solving and you see a quadratic, automatically you're thinking about factorizing, period. So in terms of looking at this quadratic equation, we have x squared minus x minus 12 is equal to 0. So in terms of factorizing, when it's a quadratic equation, you want the 2 brackets involved, and that's all equal to 0. So x squared, there's only one way to make it, x times x. Then we need to think of what 2 numbers can we multiply together to get 12, but take away from each other to get, or take away or add from each other to get minus 1. So I'm going to put minus 1 or 12. Yeah, multiply to make minus 12. I've really put the wrong number there. Adding to get minus 1. So there's a way of working this out to make life easier. What we can do is we can work out what we can just work out the different ways of making 12. So you can have 2 times 6, 4 times 3, and you can have 1 times 12. So 1 times 12 will not be a combination because that's way too much of a gap to be making a difference of 1. 2 and the 6 definitely won't make a difference of 1 either. But we know the 4 and the 3 can make a difference of 1. So looking at them, because we're trying to make minus 12, we'll try with both. So let's say if we have when it's minus 4 and positive 3, that could actually work because minus 4 plus 3 is equal to minus 1. But if you had minus 3 plus 4, that would not work because that would give you an answer of positive 1. Remember, we're trying to make minus x, not plus x. So that's going to be our numbers in the brackets. Then the last bit, but not least, which some students tend to forget, is, okay, you factorize, which is great. But solving basically means you're trying to work out the values of x. If we know that these brackets multiplied each other is equal to 0, what that's basically going to mean is that each bracket could potentially be equal to 0. So x minus 4 can be equal to 0. X plus 3 is equal to 0. Then literally to work out the solutions from x, rearrange the equations to work out what x is equal to. So if we had to make the x the subject here, we would plus 4 on both sides, which would leave us with x equal to 4. And if we were trying to make x the subject here, we would minus 3 from each side, which would leave us with x is equal to minus 3. Therefore, the final answer is x is equal to 4 and minus 3, not the values in the bracket. So always make each bracket equal to 0 first, then rearrange it, but don't use the values in your bracket as your answer for solving. Right. So moving on to question 13, we've got a bit of ratios going on. So we're basically trying to work out the ratio of e to g. So we know from e to f, we've got a 2 to 3 ratio. But we know from f to g, we've got a 5 to 4 ratio, which is quite interesting. So what we can do is we can basically work out the common factor between 5 and 3, which if you multiply them both together, that would leave us with 15. So therefore, because we know the common factor between 5 and 3 is 15, the reason why we're finding common factor is because they're both f's, so we might as well make the f the same. Then it's easier to make everything else equal to each other. So if we make them both 15, that means we would have to times both equations. Well, for the first, not equation, sorry, for the first ratio, we would have to times the 3 by 5 to get 15. And so you'd have to times the 2 by 5. Whatever you do to one side, do to the other. So then that would leave us with a new ratio of 10 to 5, which is the same as 2 to 3. Then for the second one, to get from 5 to 15, we would times by 3. And so do the same with the 4, and you're left with a ratio of 15 to 12. So therefore, if we're trying to make E and G equal to each other as a ratio, it's going to be the same as 10 to 12. And if we simplify that ratio, we would be left with, so divide them both by 2, you'd be left with 5 to 6. We can't simplify that any further, and that's our final answer. So moving on to question 14. Question 14, we've got a nice probability question. So it's basically got these brackets and these signs. So it's just about knowing the signs. So whenever you've got a dash in front of a letter in probability, so for instance, if I've got a dash in front of x, it basically means not x. So this dash here is going to be equivalent to not a. This sign here means or. So basically, this probability, if I'm to translate it, is the probability of not A or B. So now that I've translated it, it's going to make my life 10 times easier. So not A. If I'm going to shade the parts that are not A, so A is this circle here. But if I'm shading parts that are not A, that's going to really and truly include all this space plus all the outside. And then because it's a probability of or, it's going to be basically the probability included of the not A's plus the including the probabilities of the B. So if it's the A or the B, we've already got the B as well here. But then because it's an or question, not an and sign, you can include the middle part, because even though the middle part includes A and we want not A, the middle part also includes B. So just notice whenever it's a probability of an or, you want to include all the different probabilities. If it was just not A and B, then the middle part would have not been included. Yeah. And also the outside, no, the outside would be included, but the middle part would not be included. So focusing on that, looking at the values involved. So we've got 0.15 shaded and we have 0.35 shaded, but also we need to work out the probability of the outside shaded space because they haven't written the value down. So total probability is always equal to 1. And so to work out the outside, we can do 1 minus 0.3 minus 0.15 minus 0.35. And that's going to leave us with, so 1 minus 0.3 is 0.7. 0.7 minus 0.15 is equal to 0.55. And 0.55 minus 0.35 is equal to 0.25. Sorry, equal to 0.2. So if we do the 0.15 plus the 0.35 plus the 0.2, 0.15 plus 0.35 leaves us with 0.5 plus 0.2, and we're left with an answer of 0.7. And that's that. Or, I put or for a reason, there is a quick way of working it out. If we know the total probability is 1, and we know that the only bit that's not included is the 0.3, you could just do 1 minus 0.3. and that also gives you 0.7. But I wanted to show both routes because I feel like, again, it's very important to know more than one way. Right. So looking at question 15, we've got box plots, which I'm actually planning on doing a video very soon. That's my next video, box plots. So moving on, it says on average, which supermarket has the lowest queuing time? So in terms of looking at the supermarkets with the lowest queuing time, all we need to look at is, first of all, it says that in the survey, queuing times at supermarket checkouts were recorded, and it says a sample of 50 not companies, 50 customers were taken at supermarkets A, B, C, D, E. So in terms of on average, that's the key. This is where they're going to trick people out. Notice how they put on average. They didn't say which supermarket has the lowest time, because really and truly, the supermarket with the lowest time would be D. But because it says on average, averages basically mean either your mean, your mode, or your median. They're the averages that we use in maths. In box plots, the main median, sorry, jumping the gun, the main average that we use is your median. And in your box plot, the medians are represented by the lines in the middle of the boxes. And so because it says on average, which supermarket has the lowest queuing time, we're basically going to look at the median value that's the lowest. And the one with the lowest median value is C with the value of 4 minutes. And therefore, the answer is not going to be D, but it's going to be C. Because it has the lowest median value of 4. Yeah, okay. So looking at question 15b now, it says, which supermarket were the queuing times most consistent? So in terms of consistency of the queuing times, you're basically looking at the queuing times that, are looking closest together. That's what it means by consistent. Not too much of a range. So in terms of looking at that, if I put both pages on, just so you can see that. So in terms of looking at that, we're really focusing on something that we call in maths the interquartile range. So with box plots, this range is the difference between your upper quartile, so upper quartile minus your lower quartile gives us the interquartile range. So your upper quartiles, I'll put them in red, are these values because they're on the upper end of the box plot. And the lower quartiles, which I'll put in green, or in blue, sorry, are these values here. I'll rub out that arrow so it's less confusing. So we got, oh, that is not the color we want. So that was black, the median, and this was blue. And that was black. All right, so looking at these, you wouldn't even need to technically work it out. You can just even roughly just look at it. So I'll remove the colors just so it's less confusing. But before I do that, your interquartile range is basically the gap between those two colors. So now that you know it's the gap, aka the length of the box, you're basically looking for the smallest box, because the smallest box would mean there's not much difference between the values, so it's more consistent. So really and truly, the smallest box is B. So B is therefore going to be the one with the queuing times that are most consistent, because its interquartile range is the smallest or lowest, or you can say anything along those lines. So having a look at question 16. So 16, it basically wants us to circle the number that is closest value of 29 cubed. Remember, this is a non-calculated paper, so you cannot just stick this in your calculator to work it out. So if we're going to be looking for an estimate, what we can do is, I would round 29 to 30, because 30 is a way nicer number to deal with than 29. So then 30 cubed, right, is equal to 30 times 30 times 30. So we know that 3 times 3 times 3 is 27. So 3 times 3 times 3 is 27. I'm going to rewrite this because that's just ugly what I've done. Then it has 3 zeros, so just stick those zeros on. That's a really quick shortcut. So you know it's going to be roughly that. So we're going to go for that. All the other values are just way too small. And that's that part. Then question 17, what says work out the exact value of 3 over 4 to the power of minus 3. So any time that it mentions exact in maths, leave it as a fraction. Do not put it as a decimal. Either leave it as a fraction, as a surd, but do not put it as a decimal because that is not exact. Screaming with emphasis because it's very important. So if we have a look, right, whenever you've got to a negative power, I think I mentioned this in the Edexcel past paper if you watch that, but whenever you've got a negative power, you flip the fraction. So 3 over 4, flip it, and that would become 4 over 3 to the power of 3. Because once you flipped it, you can remove the negative. Then all we're going to do is cube everything. So you're going to do 4 cubed and 3 cubes. So 4 cubed is 64, 3 cubed is 27, and that's literally your final answer. We're not going to change it any further, and we can't really simplify it any further, so we're just going to leave it as that. Right, good. On to question 18. If you've made it this far, well done. Right, so Beth and Maya translate documents from Spanish to English. Ooh, come on, Beth and Maya. Anyways, a set of documents that would take Beth 8 days would take Maya 10 days. Right, so Beth starts to translate the documents. After 2 days, Beth and Maya both work on the translating documents, which makes sense because they've got a 2-day difference between them. So then it says, how many more days will it take to complete the document? You must show you're working out, right? So after 2 days, Maya starts working on it, right? Because in this case, even though it takes Maya longer, it mentions how Beth was the one that has started translating first. So if it says after 2 days, then Maya starts, that means Beth has already done 2 out of 8 days. And if we simplify that as a fraction, that's a quarter. So really and truly, after 2 days, a quarter has been done. Yeah? And so there is 3/4 left. Okay? So let's just assume, for the sake of the fact that, you know, you've got 8 days and you've got 10 days, let's just assume that, I don't know, we can think of a random number to assume, by the way. It doesn't need to be a particular number of papers, but you want to pick a nice number. So I'm going to go with 40. Let's assume there are 40 papers, right? So if there's 40 papers, and I put Beth and Maya, technically, because a quarter of the work has been done, that means there are 30 papers left to do. Because a quarter of 40 is 10, take it out of 40, you've got 30. So if we know that Beth has, so I'll put 6 days left, Maya has still got her 10 days remaining after the 2 days. So if Beth has 6 days left and she's got to get 30 papers done, she's going to be going at a rate of 5 papers per day. Yeah, we can agree on that. Maya hasn't started yet though, and let's say if there's a total of 40 papers and she's got 10 days, Maya's going to be doing about 40 papers per day. Okay, so in order to work out now how many days it's going to take, how many more days it will take to complete the work, we would have to do 40, sorry, not 40, sorry, 30, because there was 30 papers left. Yeah, we've got 30 papers left, right? Divided by how many papers Beth does in one day and how many papers Maya does in one day. So altogether in one day, these girls are going to do nine papers per day. Bearing in mind that, you know, based on us assuming that there was 40 papers in total. So if we simplify this as a fraction, divide both top and bottom by 3, you've got 10 over 3. And as a mixed number, that's 3 1/4. Sorry, 3 1/3 days. So because you can't really have 3 1/3 of a day, we're going to round that up to about 4 days. We're not going to say 3 days because if it's taking longer than 3 days, then it won't take 3 days to complete. But we're just going to say roughly 4 days. So the answer will be 4. So with this type of question, we had to work out how much has been done, how much is left. Then, because we knew how many papers were left, we were trying to work out that after the 2 days, how many days is it going to take to work out to complete what was left. Then we now had to use the fact that Beth had worked first, work out how much Beth would do in a day, how much Maya would do in a day to complete the task, and then divide that by how much was left. That's basically it. So, on to question 9. We've got a chess club. In the chess club, we've got X boys and Y girls. So it says if 5 more boys and 8 more girls join, there would be half as many girls as boys. Right, let's have a look at this. And it wants us to show that Y is equal to 2x plus 2. I mentioned show that in my Edexcel paper, just basically saying that if you have a show that question, don't use it in your calculation. That's what you're trying to show that the answer is equal to. So it says that if 5 more boys and 8 more girls join, there will be half as much, right? So chess club is equal to X plus Y. Yeah, we can agree on that, okay? So X plus Y is equal to the total, okay? It's saying that 5 more boys join, so the boys are now X plus 5. And it says that 8 more girls join, so the girls are now Y plus 8. And it says that that's going to be equal to, it says that if 5 more boys, 8 more girls join, then there will be half as many boys as girls. So then technically that's going to be equal to, so if we've got half as many boys as girls, that's going to end up being something else. So if we know that boys is X, and we know that there's half as many boys as girls, there's basically, that's the same as saying there will be, so the boys, if I rewrite this, boys, so that's going to be equal to our total, right? Boys is half as much. So technically to work out, so that means to get the value of girls, we would times the number of boys by 2. So if our boys is now X plus 5, times that by 2, that's going to equal to our value of girls, right? So AKA, that's the same as saying, or since there's half as many boys, some people can write it as X plus 5 over 2, aka times a half, is equal to, X plus 5 is equal to Y plus 8 over 2, because half as many girls is equal to boys. So anyways, we'll go with the first one that I wrote. So looking at that, we're going to expand the brackets. So that's going to leave us with 2x plus 5 is equal to y plus 8. Then, oh, not plus 5, plus 10. Purely because that times that. So then if we now collect all, well, because we're trying to leave it in the format of y is equal to, we can try and make y the subject. So if we take away 8 from both sides, we'll be left with 2x plus 10 minus 8 is equal to y. 10 minus 8 will leave us with an answer of positive 2. And that's how we've shown what they want us to show. So in part B, they're changing it up a little bit. They're saying that if instead 10 more boys and 1 girl join, there will be the same number of boys and girls. Which basically means that if 10 more boys join, so x plus 10, that's basically going to be equal to y plus 1. So I wouldn't need the bracket this time because there's nothing multiplying it on the outside. So then now we need to work out what y and x are. So what we can do is simultaneous equations. So first thing what we're going to do is, if I move it out, we're going to make y is equal to. So take away 1 from both sides. You're then left with x plus 9 is equal to y. Okay, so now we know what y is equal to x plus 9. And then if we have a look at, so onto our simultaneous equation now. So we're going to use the equation up here. So we'll have our 2x plus 2 is equal to y. And we're going to have our x plus 9 is equal to y. So what we can do is take away both equations for each other. So that's going to leave us with 0. So it's going to be 2x minus x will be x. Positive 2 minus 9 leaves us with minus 7. So x minus 7 is equal to 0. So therefore x would be equal to 7. Then we're going to substitute x is equal to 7 into this up here. So then it will be 7 plus 10 is equal to y plus 1. 7 plus 10 is 17. That's equal to y plus 1. So then y, if you take away 1 from both sides, y is going to be equal to 16. So our final answers are going to be 7 and 16. Okay, and I do have a video on linear simultaneous equations, which I will add in the description and the link above. So, having a look at question 20, guys, we're doing so well, honestly. Well done if you've made it this far. So, it's a proof question. We're basically trying to prove that QS is not a diameter of the circle, which was quite interesting because, you know, looking at it, you would think it's a diameter, but trust me, it's not. So, the first thing for that is for QS, so again, I mentioned it in my Excel video, but long story short, for proof questions, I always look at the number of marks. So if it's 4 marks, I'm trying to basically make 4 points. So the first thing is, for QS to be a diameter, that means, so I'll draw a circle so you can see what I'm on about. So remember, diameter is basically a line that goes from one part of the circle to the other, but it has to cross the center. That's a diameter. So that would be a diameter. That would be a diameter. So yeah, if it doesn't cross the center, they're not diameters. So redraw that. So if we have a look at this diameter, so having a look, if we now relate it to, so if I put that as Q and then S, so we've got an R and then a P. This is assuming that it's a diameter, by the way. So dun 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 dun. Alright, so the reason why I've drawn that is because if you have a diameter per se, and then you've got another like point like this, that's going from one point that's part of the diameter to another point of the circle, back to another point that's part of the diameter. Long story short, it will have to be 90 degrees. And that's basically based on the circle theorem, which I mentioned in my circle theorem videos, that anytime that you've got a diameter and then any angle that you make within the same segment, there would be 90 degrees. So let's have a look at that. So for QS to be a diameter, that means QPS must be 90 degrees, right? So this must be 90 degrees. So it says that XPS is an isosceles triangle, which makes sense because we got the isosceles lines. And so with an isosceles triangle, we know that the angle here and the angle here would both be the same. We know in a triangle, so XPS is isosceles, right? So then to work out the angle XSP, so XSP and both RPS, we would have to do 180 take away 50 divided by 2 because we know the two angles in the isosceles are the same. And if we were to do that, we'd be left with 65 degrees. So they are both 65 degrees. And so assuming that, that would mean that if that's equal to 90 degrees, that means we're technically saying that this is meant to be 25 degrees because we know that 90 minus 65 would be 25. But that may not be the case. And the reason why that is not the case is because if we look at this angle here, so the angle, so I'm just drawing my angle sign, the angle RSX, oh sorry, QSR, so angle QSR has to be equal to, so this angle here is the same as this one. So QSR is equal to QPR. And so if that's the case, let me just scroll down. If really and truly that's the case, then that means that that angle there is 27 degrees, as well as that one there, which is also 27 degrees. So I put equals to 27 degrees. And so because 27 degrees is not equal to the 25 degrees that we should have had, therefore it cannot be a diameter. So I hope that made sense. All right, moving on to question 21. It's to do with quadratic sequences, so we're trying to work out the nth term. So in terms of quadratic sequences, in terms of working out the nth term, the first thing is work out the difference between the numbers. So the first one is 15, then we've got 19, then we've got 23, right? And then now we need to work out the differences between those numbers. So I'm just going to rewrite it at the bottom so we have enough space. So we've got 4, 4, 4. Because we can see that the differences are nice and the same, now for a quadratic sequence, if you're trying to work out the nth term, I'm just going to write the formula for it here. So if we're working out the first number in front of the n squared, you need to do the value that you got for the differences that were all the same, which is 4, divided by 2, which would leave you with 2. So you know that first bit of the n squared is 2n squared. So now we've got 2n squared. We're going to write our first 4 values for 2n squared when n is equal to 1, 2, 3, and 4. And for 2n squared, we would get values of 2, and we would get 8, 18, and 32. Then that means the rest of it, the bn plus the c, has to be equal to, because the first term is 11, that means that would have to be equal to 9, because 2 plus 9 is 11. So then, yeah, basically work out the differences of the actual term that you're trying to get by what we have so far. So 26 minus 8 would leave us with 18, 45 minus 18 would leave us with 27, and then 68 minus 32 would leave us with 36. So because the bn plus c is meant to be equal to that, and then I'll put what the nth term is. Wow, they really say doctor's handwriting is really messy. So 11, 26, 45, soon to be doctor, correction. But anyways, carrying on to this. So that is what the nth term was meant to be. So in terms of now working out the rest of it, if we have a look, right, at the bn plus c, can you notice how they're all multiples of 9? And so really and truly, if they're all multiples of 9, then we would have 9n, and there's no plus c that we're going to be adding on because it's consistent. If it was to say that that bn plus c part was not consistent, then yes, we would have had to take away from each other again and work out what the b is and then work out what the c is. But because it's consistent, all you would have to do is stick that number they're all a multiply by in front of n. So really and truly, the answer is 2n squared plus 9n. So that is our final answer for that. So I hope that made sense. So moving on to question 22, we're solving this. Right, so solve. So we've got fractions. Adding fractions, you need to have the same denominators. So what we're going to end up doing is the x plus 4 is going to be multiplied. I don't know why I just stuck the brackets out there. We're going to multiply both top and bottom by x minus 2. And then the other one, we're going to multiply both top and bottom by x plus 4. That's going to leave us with, so the first bit for the first fraction will be x squared plus 2x over x plus 4, x minus 2. And then add that onto the second set, which it would be 7x plus 4. Then we can simplify the top part of the fraction. So collect like terms. So it's going to be x squared because there's only one set of x squared on the top. Then we've got a 2x and we've got a 7x. Add them together, you've got 9x. So, oh, I just realized that would not be a positive because it's a negative. It would be negative 2x. So negative 2x plus 7x will leave us with 5x. And then also realized. 7 times 4 would leave us with 28. So that's going to be plus 28. And that's going to be over x plus 4 times x minus 2 is equal to 1. So what we can do is we can multiply both sides by the denominator. And that's going to leave us with x squared plus 5x plus 28 is equal to the x plus 4 times x minus 2. Then we can expand all the brackets on the right hand side, which would be x squared plus 4x minus 2x minus 8. But then if you've got plus 4x minus 2x, that's going to leave you with positive 2x. And then we still got the minus 8 equal to the x squared plus 5x plus the 28. And then what we can do is, if we take away x squared from both sides, we're left with 5x plus 28 is equal to 2x minus 8. Collect all the x's together, collect all the numbers together. So if we take away 2x from both sides, and then if we move the page down, take away 2x from both sides, that would leave us with 3x plus 28 is equal to minus 8. Then if we take away 28 from both sides, we would be left with 3x is equal to minus 36. Divide both sides by 3, and we would be left with x is equal to minus 12. So that is minus 12. So that would be our final answer. And then moving on to question 23, it basically says prisms A and B are similar. It's a nice similarity question. So it basically wants us to work out the area of the cross section of B. So having a look, it says that the volume of prism A is 480 centimeters cubed, but it's only given us the length of prism B. And it says that the cross-sectional area of A to B is a ratio of 4 to 9. So for the areas, area A to area B, we've got 4 to 9, right? We've got a 4 to 9 ratio. But remember for its length, so just to remind you, so for the length, the difference is to work out the scale factor. For the areas, though, it's going to be the scale factor squared. And for the volume, it's the scale factor cubed. So now that I've said that, if we know that the ratio for the areas is 4 to 9, then therefore to work out the scale factor, we're going to square root the ratio. So if we square root the ratio, then it's basically their ratios are also the same as saying 2 to 3. So now we've essentially worked out their scale factors as a ratio. So then now to work out the length of A, So to work out the length of A, if we know that the scale factor for the lengths of A and B, if I zoom out, there we go. So if I knew that the length of B is 30, then the length of A would be 20. So that would be 20 centimeters. Then now, last but not least, in terms of working out the area of the cross section of B, if we know the length of A, right, we know that volume is equal to area times length. So now, if I know the length of B, sorry, why am I talking about B so much? So yeah, volume is equal to area times length. So if I know the length of B, there we go, I can work out the cross-sectional area of B. And how I can work that out is, first of all, I'm going to work out the cross-sectional area of A, then use the ratio to help us out. So to work out the area of A, I'm basically going to rearrange this formula over here. which would leave me to end up doing the volume divided by the length. The volume for A is 480. Divided by its length of 20 is going to leave me with an answer of 24 centimeters squared. Because I know that the ratio in terms of area was a 4:9 ratio, and the area for A is 24, then therefore, to work out what the area of B is, so BA, to get to 24, I would do 4 times 6, and then to get to what the area of B is, I'm going to do times 6 on the other side, and so that would be 54, because 9 times 6 is 54. So now I know what the area of B is. Oh, that's it. That's my final answer. So yeah, the area of B is 54 centimeters squared. So try and remember the scale factor stuff and the equation for the volume. That really helps with similarity questions. So yeah. Moving on, nearly there, guys. So let me just put the page correctly. Bam. All right. So question 24. It says that show that 2 square root over 5 square root is equal to, minus square root of 3 over to square root of 10. Right. We're trying to show that it can be written as C root D over 10. So the first thing we're going to do is, I always like to rewrite out the question. That way it gives me guidance of how to begin. So the first thing that we are going to do is, these are surds. So reading truly, these are surds, which I was also planning of doing a video very soon as well. So stay tuned if you want help with those. So when it comes to surds, the first thing we're going to do, oh, I forgot the square root there. We need to rationalize the surds, right? So to rationalize the surds, not rationalize. Because we're taken away from 2 surds, notice how it's kind of still like a fraction format. Remember, the basis of fractions is whenever you're adding or taking away fractions, you want the denominators to be the same. So if I want the denominators to be the same, I'm going to change this fraction. So I'm going to do that by timesing both top and bottom by root 2. And if I was to do that, I would be left with 2. So the 2 roots times each other will leave you with root 12. And then the 2 roots times each other at the bottom will leave you with root 10. So now I've got this, take away the root 3 over root 10. So the denominator is not going to change. So I'm going to have 2 root 12 minus root 3 over root 10. Now, the 2 root 12 can change, because root 12 is the same as saying root 3 times root 4. And we know that the square root of 4 is 2. So that's essentially the same as saying 2 times root 3. So if I've got 2 times root 3, remember, times the 2 on the outside, that's going to leave us with 4 root 3. So then now I'm going to have 4 root 3 minus root 3 over root 10. 4 root 3 minus another root 3 will leave me with 3 root 3 over root 10. And so the last thing is to do is, notice how the 10 at the bottom is a whole number this time. It's not the surd. And a way of converting a surd fraction into a whole number at the bottom is you need to rationalize it, aka times both the top and the bottom by root 10. And if we are to do that, that would leave us with, the bottom would just be 10, because aka would be root 100, and the square root of 100 is 10. And then if we had to do 3 root 3 times root 10, that's going to leave us with 3 root 30, and then root 30 is going to be simplified into, so we've got 3 root 30 over 10. And then with the root 30, we could essentially change this. But the reason why we are not going to change it is because it specifically wants our answer in the format of one whole number on the outside, the surd, and then the root 10 at the bottom. And we've got that. And so that's why that's going to be our final answer. So moving on to 25. Question 25. So we've got a quadratic curve, and then it says that it intersects the axes of all these points, and it wants us to work out the equation of the curve. So because it's a quadratic curve, we know that the quadratic formula is ax squared plus bx plus c. So we really and truly want it in this format. So our plus c is our y-intercept. We can see that it crosses the y-axis at 18. So we've got that bit as 18. So we've got ax squared plus bx plus 18. But we need to work out the rest of it. So we've got the solutions minus 3, 0 and 3, 0. So what we can do is that we can substitute their x values, and we can basically solve this using linear simultaneous equations. So what I mean by that is, if we know that the formula is ax squared plus bx plus 18, right? So if I look at point number 1, so aka the point where 3, 0, which is there, and I substitute those values in. So the x values were 3. So that would be 3 squared, which is 9. So it'll be 9a plus 3b plus 18 is equal to 0. And then because it's equal to our y, and then for the minus 3, 0, it would be, again, minus 3 squared will be positive 9 as well. So it'll be 9a, but this time minus 3b plus 18 is equal to 0. So then, because everything is equal to 0, we can really and truly rearrange this by taking away 18 from both of them. And by doing that, we would be left with both of those are equal to negative 18. Then, if we take away from both sides, we would be left with 9a minus 9a is 0, but 3b minus minus 3b, remember if you've got two negatives together, they become a positive. So you've got 6b is equal to, so minus 18 minus minus 18 will also be equal to 0. So essentially, b is equal to 0. And so if b is equal to 0, we can work out what a is. So if b is equal to 0, then essentially, if we have 9a, so if we look at the first one, if we have 9a plus 3b is equal to minus 18, and we know b is equal to 0, cancel that out, and we've got 9a is equal to minus 18. And if we rearrange that, if we do minus 18 divided by 9, we're left with an answer of minus 2. So then a is equal to minus 2. And so because of that, the full equation will be minus 2x squared. B is equal to 0, so that's not going to be part of it. So it's going to be minus 2x squared plus 18 is equal to y. Or you can write it as y is equal to minus 2x squared plus 18, which I would prefer to write it this way, to be honest. So yeah, that's the final answer. All right, guys, we do not have long left, I promise you. I think we've got 2 questions left. So looking at question 26, question set 26 says that the area of a triangle is 25 root 3, and it basically wants to work out what the value of W is equal to. So this is going to involve us using, because we're trying to work out an area, right? But notice how this is not your typical right angle triangle. So whenever you're trying to work out an area of a triangle that's not right angle, you're going to end up using the other equation, which is area of a triangle is equal to half AB sine C. So remember, that's what we use for an area of a triangle if it's not a right angle triangle. So in terms of that, what that means is our C is the angle, and the AB are basically the 2 other lengths that are mentioned. So if we've got this length here, so how do I explain? So with a triangle that's not right angle, just to quickly summarize, so if that's big C, then that would be little c. So your little letter is always opposite the big letter, aka the angle. So then if that is that, then if I Just show you what I mean. So then if that's going to be little c, then either of the other ones will be a or b. Doesn't matter which ones your a or b are going to be. So if I substitute those values in, it's going to end up being half times 20 times x times sine of 60. We know, because I showed the table not long ago, that sine 60 was equal to root 3 over 2. But then if we did a half times 20, that's going to be 10. 10 times x will be 10x. So then we've got 10x times root 3 over 2. And that's going to be equal to our area, which is 25 root 3. So if I scroll down just so we have enough space. So then if we have 10x times root 3, that's going to be 10x root 3 over 2 is equal to 25 root 3. So then now, because they've got root 3 on both of them, we can cancel them out. And then because we've got 10x divided by 2, we know that 10 divided by 2 is 5. So essentially 25 is equal to 5x. So then x is going to be equal to 5. So now we know what x is equal to. We're trying to work out what w is equal to. So I'll put that as 5. So now another thing is, whenever you've got triangles that are not right angles, not only are you going to use the half AB sine C, but these are cases where you may either use sine rule or cosine rule. So because we're trying to work out another length, and we've got so we essentially have 3 lengths, 1 angle, aka we're going to be using cosine rule. And the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So because we're just going to use the 60 degrees as our cos A, because it's the only angle that we know. So because 60 degrees is opposite W, then our A is going to be equal to W. So W squared will be equal to all of that. So then basically W squared is going to be equal to B squared plus C squared, aka 5 squared plus 20 squared, which 5 squared is 25, plus 20 squared, which is 400. Then we've got minus 2 times 5 times 20. So 2 times 5 is 10. 10 times 20, which is 200. So that's going to be minus 200 times. So cos 60 is equal to a half. Again, use the table. So 400 plus 25 is 425. 425 minus 200 times a half is 100. So then that's going to leave us with 325. Remember, that's equal to w squared. So in terms of working out what w is actually equal to, we need to work out the square root of 325. Obviously, 325 is not a squared number. So this is going to leave our number in a third format. So now we need to think of all the different ways we can make 25 by multiplying. So 325 by multiplying. So one way is if you were to do root 25 times root 13, that would leave you with 325. And so because of that, we know the square root of 25 is equal to 5, times that by root 13, and that leaves you with an answer of 5 root 13. Now, a way of working that step out, because I bet a lot of people are like, what? How did you get that? So in terms of when it comes to finding a simplified third, you basically want to think of one squared number. So you need to think of a squared times a non-squared number. So we know 25 is a squared number. So I would have gone up in the square numbers. So I would have looked at from 1, 4, 9, 16, so on, and look at which squared numbers do you think are most likely to be a multiple of 325. That gives you a clue. Then think of what number would be multiplied by that squared number to give the answer that you've got, which is 325, and then that helps you to work out your simplified third. So that is literally the best technique for simplifying a third. Keep saying a third. A third. You need to think of your squared number times your non-squared number. So that's that. Then we're literally on to the last question of the day. We've made it to the end, guys. Honestly, proud. So on to 27A. The first part is it wants us to circle the value of cos 180 minus A. So it says that A is an acute angle, but essentially we don't really know what A is equal to. But what we do know is that if we have a look at the graph, right, it says that K is a positive value. So if we were to do 180 minus a, realistically, that's not going to leave us in the positive end, because we've got 180, right? So the distance between there and there is our a, okay? But if we're to do 180, which is a negative answer, minus our a, we would be left with a value of about here. The whole point is if you did 180 minus a, you're going to end up in the negative range. And so if we know that positive a is equal to a, k, then negative a would be equal to k, right? So it's just going to be minus k. Then last bit is we need to circle the value of 360 plus a. So if it's 360 plus a, so I'm just going to show the rest of the graph. So 360 plus a is showing to be in the positive range. We've got a value within the positive range. So because we know that 360 is equal to 1, remember with the cosine and the sine graphs, so it's after you've reached that 360 cycle, essentially, yeah, it's just going to be there. So they're going to be your points. So really and truly, it's still going to be a value of k, even if you do 360 plus a. So we've reached the end, guys. I really hope that was useful. I really do. Please message in the not message, sorry, leave a comment down below if you still have any questions. I'll also leave the Instagram name in the description down below in case you want to message me on Instagram if you have any questions. But yes, I hope that was useful for the full AQA run walkthrough of the paper. Thanks for watching and see you in the next video. Or not see you, but stay tuned and like, comment, and subscribe, please, please, please. But yeah, thanks for watching. Bye, guys.